All right, here's example 3. Now, as we're practicing these, we're noticing that we have to look for where there's a graph, or I'm sorry, an x value where it'd be discontinuous. Well, again, a piecewise function would be a line with a slope of 1 here, a constant function, and a parabola. So those don't have any issues as far as, values that are undefined, or, the domain of all of those are all real numbers is the way to think of it. But we definitely have to look at x being -1. Is that a discontinuity, since we have 3 different kind of things happening here with that? So what do? Once again, we always want to see, is f of -1 in this case defined? So f of -1, where would we plug that in? We would plug it straight into here and we would get 3. Okay, sweet. It is defined. What about the limit as x approaches -1? Well, here's the deal. Since it's a piecewise function like this, we have to look at it from the left and from the right. So let's look at this from the left. That would mean as we approach it from the left, well, that's going to be this top one right up here. X value is less than -1. This is what's happening. So we would use x plus 4 there. Well, again, no issues. Direct substitute, -1 plus 4. We are going to get a value of 3. Hey, look at that. We have a left-handed limit of 3. Okay, well, let's look at it from the right. What would happen as we approach -1 from the right? Well, that would be this one. So now I put in, or I use x squared, that part of the function. Well, what would that equal? Directly substitute, totally okay here, -1 squared, and we get 1. Well, if you get one value from the left and another value from the right, what's that tell you? That tells you that the limit as x approaches -1 of the function, and then I'm running out of room here, but it does not exist. Okay, so we do not have a limit existing. So back up here, was f of -1 down here, was that defined? Yeah, sure was. It was 3. Did the limit exist? No, it does not. Well, then we can't even check to see if they're the same because the limit does not exist. So we have discontinuity where at x equals -1. Now, what is it going to be? Removable or non-removable? Okay, well, let's go back to that sheet that I've been referring to. A removable whole would be if the limit exists, but the value doesn't. Well, we didn't have that. We had this situation, correct? Because from the left, it approaches one number. From the right, it approaches another number. That would be a break. That would be a non-removable. And then we would call it a break. Remember, we want to answer the big 3 questions each time we're going through this and we show our work. And these are what we're going to use. Okay, so we're going to give you 3 problems just to give you a try at them for today. And I know it might be a little rocky road here, but we will get there. So hopefully these examples helped.